Welcome to the another lecture on communication engineering. I'm Ramji, working as an assistant professor in the Department of Electronics and Communication Engineering at GCE Tanjavur. So in this lecture, we are going to discuss about what is angle modulation and how this angle modulated wave can be generated and detected. Angle modulation is a process in which the frequency or the phase of the carrier is changed in accordance with the amplitude of the modulating signal. There are two types of angle modulation. One is frequency modulation and another one is phase modulation. What is frequency modulation? The frequency of the carrier signal is changed in accordance with the amplitude of the modulating signal. And phase modulation, the phase of the carrier signal is changed in accordance with the amplitude of the modulating signal. Here, so this is a carrier signal and this is a modulating signal. And in the case of frequency modulation, the frequency of the carrier signal is changed according to the amplitude of the modulating signal. And in this case, the maximum frequency deviation will occur when we have the maximum voltage and the minimum voltage. In the case of phase modulation, the maximum frequency deviation will occur when there is a zero crossing from negative to positive or from positive to negative. So this is a mathematical expression for angle modulated signal E of t equal to Ec into sine omega ct plus theta t. E of t is angle modulated signal, Ec is a peak amplitude of the carrier, and omega c is angular frequency of the carrier signal, and theta of t is a instantaneous phase deviations. Here theta of t is a phase deviation, theta dash t is a frequency deviation. And there is a relation between phase deviation and the frequency deviation, theta of t equal to integral theta dash t into dt. In phase modulation, instantaneous phase deviation is proportional to modulating signal voltage, that is theta of t equal to k into em of t. Here k is a deviation sensitivity of phase. Similarly, in frequency modulation, instantaneous frequency deviation theta dash t is proportional to modulating signal voltage, that is theta dash t equal to k1 into em of t. Here k1 is a deviation sensitivity of frequency. So putting theta of t in e of t, we get the PM equation E of t equal to Ec into sine omega ct plus k into em cos omega mt. Similarly, putting theta of t in terms of theta dash t, we get the frequency modulated signal equation E of t equal to Ec into sine omega ct plus k1 into em divided by omega m into sine omega mt. And the modulation index in Fm is directly proportional to peak modulating signal voltage and inversely proportional to modulating signal frequency. M equal to k1 into em by omega m. Here omega m is equal to 2 pi fm. So substitute m equal to k1 into em divided by 2 pi fm. Here k1 into em divided by 2 pi is a frequency deviations. It is known as del and its unit is hertz. So m equal to del divided by fm. And the percentage modulation in Fm is a ratio of actual frequency deviation to the maximum allowable frequency deviations. And what is deviation ratio in Fm? It is a ratio of maximum frequency deviation to the maximum modulating signal frequency Fm. There are two types of Fm. One is narrowband Fm and another one is wideband Fm. If the modulation index is small and the bandwidth is narrow, then the Fm is called narrowband Fm. And if the modulation index is high and the bandwidth is wide, then the Fm is called wideband Fm. So we can derive the mathematical expression for narrowband Fm. So for this, we take the general equation of Fm is E of t equal to Ec into cos 2 pi fct plus m into sin 2 pi fmt. Here m is a modulation index, that is k1 into em divided by omega m. So expand this equations. So this is like a cos a plus b. So cos a cos b minus sin a sin b. In the case of narrowband Fm, the modulation index is very small. So if theta is small, cos theta equal to 1 and sin theta equal to theta. So in this case, cos m sin 2 pi fmt equal to 1 and sin m sin 2 pi fmt equal to m sin 2 pi fmt. So substitute these two values in this equation. So E of t equal to EC into cos 2 pi fct minus m into EC sin 2 pi fct into sin 2 pi fmt. So this is like a sin A sin B. So we can apply 1 by 2 cos A minus B minus cos A plus B. So finally we get E of t equal to EC into cos 2 pi fct plus 1 by 2 m into EC cos 2 pi fc plus fm into t minus cos 2 pi fc minus fm into t. So this is the expression for narrowband FM. In the case of wideband FM, to derive this wideband FM, we take the general equation of FM, E of t equal to EC into cos 2 pi fct plus m into sin 2 pi fmt, and we can rewrite this equation, real part of EC into e power j 2 pi fct plus m into sin 2 pi fm into t, and this is like e power a plus b. So e power a plus b equal to e power a into e power b, substitute. Then let us assume x of t equal to EC into e power j m into sin 2 pi fmt. So in this case, so we can take E of t equal to real part of x of t into e power j 2 pi fct. Here x of t is equal to EC into e power j m sin 2 pi fmt is periodic with fundamental frequency of fm. So it can be expressed with the help of Fourier series. X of t equal to summation n equal to minus infinity infinity Cn into e power j 2 pi n into fmt, and Cn is a Fourier coefficient where Cn equal to fm integral minus 1 by 2 fm to 1 by 2 fm x of t into e power minus j 2 pi n into fm of t into dt. So we substitute what is x of t from here. X of t equal to EC into sin e power j m sin 2 pi fmt. So this is like e power a into e power b. So e power a to e power b, e power a minus b. Put y equal to 2 pi fmt. Hence the limits will change from minus pi to pi. So Cn equal to EC by 2 pi integral minus pi to pi e power j m sin y minus ny into dy. So this equation like a Bessel function of first kind. So it is commonly noted as Jn of m. So Cn equal to Jn of m into Ec. So put Cn and x of t, and x of t equal to summation n equal to minus infinity infinity Jn of m Ec into e power j 2 pi n into fm of t, and put the above value in x of t, above value of x of t in e of t. So e of t equal to real part of summation n equal to minus infinity infinity Jn of m Ec e power j 2 pi n into fm of t e power j 2 pi fct. So Ec into summation n equal to minus infinity infinity real part of jn of m e power j 2 pi fc plus n into fm of t. So we can convert real part into cos. So Ec into summation n equal to minus infinity infinity jn of m cos 2 pi fc plus n into fm of t. So the Fourier transform above equation is E of f equal to Ec by 2 summation n equal to minus infinity infinity Jn of m del of f minus fc minus n into fm plus del of f plus fc plus n into fm. So this equation is so that there are infinite number of components from minus infinity to infinity located at fc plus or minus del of fm, fc plus or minus 2 into fm, fc plus or minus 3 into fm, and so on. So this is a time varying waveform. If we take the frequency modulated signal, in the case of wideband FM, we have the infinite number of sidebands. So this is a signal for carrier frequency, and this is a signal for first sideband. So this is a signal for second sideband. So this is a signal for third sideband, and so on. And here there is a table shows that for if the modulation index m equal to 1, we have the carrier term and we have the three sidebands, three upper sidebands and three lower sidebands. So similarly, m equal to 3, we have the carrier term, the voltage of this carrier term and other sidebands. There are two ways to generate the frequency modulated signal. One is direct FM modulation and another one is indirect FM modulation. In direct FM modulation, based on the operation of Arrector diode, we can get the frequency modulated signal. At positive going modulating signal, it adds the reverse bias applied to the Arrector diode, which decreases its capacitance, and increase the carrier frequency. A negative going modulating signal subtract the bias and increase the capacitance, which decrease the carrier frequency. In the case of indirect FM modulator, modulating signal is integrated and phase modulated to get the narrowband FM. Then the frequency multiplier is used to increase the frequency deviations to get the wideband FM. To demodulate the frequency modulated signal, we use a balanced slope detector. In the case of balanced slope detector, at the primary side we use one tuned circuit, and the secondary side we use a two tuned circuit T1 and T2. When the input frequency is equal to Fc, both T1 and T2 have the same voltage, therefore Vout is 0. When the input frequency is equal to Fc plus del F, then the upper tuned circuit T1 produces a maximum voltage and T2 produces a minimum voltage, and the Vout is maximum for Fc plus del F. When the input frequency is equal to Fc minus del F, then the lower tuned circuit T2 produces a maximum voltage and T1 produces a minimum voltage, so the output Vout is minimum. So this graph is a variation of output voltage with respect to the input frequency. When the input frequency is equal to carrier frequency, the output will be 0. When the input frequency is equal to Fc plus del F, we have the maximum voltage. When the input frequency is Fc minus del F, we have the minimum voltage. And the PLL method also is used to demodulate the FM signal. PLL means phase lock loop. Here, the output frequency of voltage controlled oscillator is equal to the unmodulated carrier frequency. Phase detector generates a voltage which is proportional to difference between voltage controlled oscillator and the FM signal. Then this signal is given to the filtering and amplifications for getting the modulating signal. The next lecture will be discussing about what is super heterodyne receiver and how it is working. Thank you.